Hi, my name is Shu,
My name's Liam.
and today we're going to go over catalog components and specifically how to choose the right type of fastener and how to design the different parts for them. So here we can see the anatomy of a screw. In the A length, we have the thread length, and the B is the diameter of the screw, and then the C is the grip length, which is the unthreaded length of the screw.
The two most common types of threads are UNC and UNF, which stand for Unified National Coarse and Fine. Coarse threads are easier to assemble and they're less prone to stripping than fine threads, but they do have larger tolerances and you don't have quite the fine adjustment that you get with a fine thread. With a fine thread, however, they do take longer to fasten because you have to turn them more, but they are more vibration resistant and typically withstand higher loads and shear. In situations where you have higher loads or more precise fits, having an unthreaded shank on your bolt might be helpful. You can buy partially threaded bolts from McMaster. They are relatively cheap, but the tolerance on the shank length is high, and you only have one option for how long the threaded length is. The other option, which is a more premium option, is to buy NAS bolts, which stand for National Aerospace Standard. These come in threaded length increments of 1/16 of an inch, and they also have higher shear ratings, but they are quite premium. Now that you've chosen the type of threads you'll have on your bolt, you need to choose how you're going to install it. The different options you have available typically are limited by the size of the bolt itself, but you also need to consider what type of tool you'll be using and where this bolt will be located. If you're in a tight place, it might be more advantageous to use an Allen key, and if you need to apply higher torques, you might need something like a typical wrench to install your bolt. So the tightness and how much air you have around you are all factors that influence what type of head you get on your bolt.
There are a few different failure modes for bolts which need to be considered given your design specifications for the specific bolt. It is ideal to design bolts to be loaded axially, although if shear stress is unavoidable, it is better to design for a double shear stress scenario as seen in the second picture. Also, tap threads can strip, so ideally most of the load will be forced onto the first three threads, so you want at least three threads of engagement for your bolt. So obviously, once you've selected a bolt, you need to have a hole for it, right? So here on the bottom right, we see a very common tab and clearance hole chart. So on the first main left column under tab and clearance drill sizes is going to be kind of the whole nominal size of the screw. So basically, there are different numbers that screws fall under, and then the different major diameters for those specific screws. All these units are in English units, so inches. And then in the middle section is the tap drill. So basically, the tap drill, for if you want your hole to be threaded, you would use a tap drill. And so for softer materials like aluminum, brass, and plastics, you would use a 75% thread column. And then based on that, based on your screw size, you have a basically hole size to drill. And then on the right is the harder materials such as steel, stainless steel, and iron. And those have their own set hole sizes. Also, if you don't want any threads for your hole, you can choose either a close fit hole or a free fit hole for your clearance hole. So basically, close fit means that there is not basically any movement at all in the bolt. You want your bolt to be perfectly perpendicular in that one set location. However, if you do want some play, some movement for your bolt to move around in, you can choose a free fit hole, which is basically slightly larger than a close fit.
So now you got your bolt in a hole and you want to make sure it stays there. Bolts can tend to back out of holes just from vibration and other loads they may encounter. So a good option is to use lock nuts. There are many different types of lock nuts. The most commonly used ones are nylon insert lock nuts, also known as nylocks. These have a little ring of nylon around them so the threads actually cut into the nylon, helping the bolt stay in place. You can also buy distorted thread and flex type lock nuts. These don't involve any plastic components, so they're better at high temperatures, but they do tend to lose their locking ability after 10 or 20 different cycles. If you really have no other options, you can also use a nice thread locking compound like Loctite to just lock the threads of the nut and bolt together, or the bolt and the tapped hole together. Good luck with your nuts and bolts.